Okay, so in the previous video, when we started looking at surds, we were looking at manipulation of surds and how we can work around them. But in this video, we're going to look at how to rationalize the denominator. And why do we rationalize the denominator? We rationalize the denominator when we are dealing with expressions which has got denominators as surds. Okay. Now, we need to eliminate those denominators which are surds as much as possible. And that process is what we call rationalizing the denominator. Now, to rationalize the denominator, we have two expressions. The first expression, so expression 1, expression type 1, is of the form of 1 over root of a. When you have this type of an expression, you multiply the numerator and the denominator by root of a. Why? What do you mean? So if we have this, you multiply both the numerator and the denominator by root of a. So we're going to say root of a over root of a. You multiply. And this will give you 1 times the root of a, it will be root of a over root of a times root of a. From the previous video, if you watched it, this will just be a. Now the denominator has no surd. It has been eliminated. Expression 2. These are some of the rules that we need to know. Expression type 2 is when you have 1 over b plus or minus root of a. Here, let me branch it into 2. Plus or minus, that means we've got two expressions there. We have 1 over b plus root of a. So of this type, you still multiply the numerator and the denominator by what is down here. But you change the sign. So we do this. It will be b minus root of a over b minus root of a. So you swap the sign here, and this will eliminate this. But if you maintain the sign, it won't eliminate the side which is below. So swapping the sign enables us to eliminate the side, the side below the denominator. Then when you work out this, you discover that you're going to have 1 times this, it will be b minus root of a over, what is b times b? It will be b squared. Now take note that b times negative root of a and b times positive root of a, they will cancel. So what we're going to remain with, it will be root of a times negative root of a, which will give you negative what? Negative what? A. Let's just go about it. We have something like this. I'll write it also so that you see. So then b times root of a, this will be negative b root of a, plus we come to b times root of a, b root of a. Then root of a times root of a, negative root of a there. What we get there is just negative a. So I hope you are following how I'm arriving at the final solution here. So this will be b minus root of a over, these two will cancel, then I'll remain with b squared minus a. I'll remain with b squared minus a. Now that the denominator is no longer a surd, we have rationalized the what? The denominator in that case. Then the other one is when the b part The b part is when you have 1 over b minus root of a. Previously we had b plus root of a. This we are going to multiply. So we are going to change the sign there and multiply by b plus root of a. B plus root of a. So this will give us 1 times b plus root of a. It will be b plus root of a over b times b. It will be b squared. What we have here, it will be just the same as that. They're going to cancel. Then I'll remain with root of a times root of a, which will be just a. As right as that. Okay, so let's look at some examples. So, example 1. Rationalize the denominator of the following. 3 root of 5 divided by 2 root of 6. How can we rationalize the denominator? Now, in this case, we are going to multiply both the numerator and the denominator by 2 root of 6, as we said. So we are going to say this will be equal to 3 root of 5 over 2 root of 6 times times 2 root of what? 6 over 2 root of what? 6. Okay, so we continue. Then when we multiply, we are going to have 3 times there. This will just give us 3. Now root of 5 times root of 6 over 2 times. Now remember, root of 6 times root of 6 is just 6. To be 2 times 6. Now because remember, from the product rule, we have this is same as 3 times 5 times 6 over 12 there. And here we are going to have 3 root of 30 over 12, and we can proceed here. 3 can go into 12, so this will be root of 30 over 4, and you are done.